So this is our control system presentation. So it's we're going to go over a bunch of programming stuff, basic stuff, a little bit more in-depth stuff, all the things you need to know to kind of get started with programming. So what we're going to learn, the FTC control system will be the main focus, obviously. Our goal here is to give you a good enough overview on a lot of topics and enough resources so that you can deep dive and experiment with whatever you want to. A great place to learn Java basics is Codecademy, and we'll post a link to that in the chat, or you can just look up Codecademy. It's a nice kind of beginner way to get into Java. And we understand that this presentation won't teach you everything about programming today, so contact us if you need to. We're happy to help with anything.
All right, let's go ahead and get started. I told there might be an issue with my audio, so let me know if something goes wrong with that. And if you have any questions throughout the presentation, either drop them in the chat and someone will read them out, or you can ask them at the question breaks. Let's get started with some control system basics. So this is all supposed to be on your robot. So this is just what's physically on whatever you're driving. So the oldest method is going to be 2 expansion hubs and a phone. The next slide will show you what an expansion hub is, so just wait a moment. This is a phone per expansion hub. This is all on the robot. It was used primarily from 2016 to 2019 before new technology was developed. This will interface with your motors and sensors. The phone is what the program is on, so you'll download to your phone, and not your phone, whatever phone you have on the robot. And the phone will communicate with the expansion hub, which will then send further communication down to your motors, your servers, your sensors, and then that is what makes the phone move. A couple of concepts is that the connection between the phone and the hub is a failure point, and it will require you to charge however many phones you need in order to make the robot work consistently. Another method is expansion hub and control hub. This was created in 2020. It's kind of an all-in-one solution. It eliminates the phone on the robot because the control hub is able to do what the phone was doing. It's able to download code onto it, and it will do all of that interfacing, all of that communication that the phone was originally going to do. So these are pictures of your expansion hub, your control hub. You've got ports on there for all of your motors, servos, sensors, etc. And this is essentially what your apparatus is going to be on your robot, and it's going to just basically do all the communication that needs done.
Sorry for all of the breaking up audio. If you have any questions on any of that, you can ask at the question break. Sorry, technical difficulties for that, but moving on. So the thing that you actually use to control your robot and connect to the expansion hubs or control hub that's on the robot is the driver station. So this is an app that you can download. You can download onto any phone, and you need an FTC legal phone, obviously, which are gone over in Game Manual 1, which actually just was released yesterday, I'm pretty sure. So you can check that to make sure that you have a legal phone for FTC. That phone will have 1 to 2 controllers plugged into it, and you can't modify or program the driver station software. It's just kind of like a hub for all of your code to like run off of and connect to the robot. So what was introduced last year, I'm pretty sure, if I'm not forgetting, was a driver hub. I'm pretty sure it was last year. And this is basically, as you can see, kind of like a bigger phone in a way. It's this block, and It doesn't require a phone. It kind of is its own phone in a way, and it also has the driver station app like downloaded onto it, so it kind of works the same way in that sense. But since it has less failure points, which means that you'll be safer against disconnects, and hopefully they won't happen as much. So the way that you actually pair your either driver station on your phone or on the Drive hub to the actual robot is by Wi-Fi pairing. So Wi-Fi Direct is used to connect the driver station app with the robot, and you need to be connected to a Wi-Fi network. We'll go over it a little bit later, but usually at tournaments, there's a Wi-Fi network that they tell you to connect to try to reduce the usage of the channels and hopefully make disconnects less likely for people. The control hub creates its own Wi-Fi network that the driver station connects to, and different channels will have different amounts of other devices. Like I said before, at tournaments, they will usually tell you what channel to connect to try to limit the amount of devices on each channel and prevent anyone from disconnecting, because that's always a rotten thing to happen. And 5 gigahertz is important to, once again, improve connection and reduce the chance that you disconnect during a match. So here's just a little, if you see on the image, you can, these are the little, how you press to connect, Wi-Fi settings. You just go to your settings and select Wi-Fi settings. So for configuring, we're going to be going over the basics. It's generally straightforward. Rev has documentation on this, and the first wiki also does, which are both great for kind of running you through this. We will post those links in the chat, and if you're watching this video later, we'll have that in the description there somewhere. Feel free to contact us if you have any issues, and we have a little video here kind of showing off configuring. So you hit the little buttons in the top and select Configure Robot. And then you hit Scan to find the devices you're connected to, and you select whatever you want. So for here, expansion hubs, and then you can go into something like motors and select what kind of motor you're using out of this list of all these different kinds of motors that could be on your robot. And then you put in the name of the motor that you're using in your code. In this case, it's called motor. You can do the same thing with servos. You can do the same thing with, as you can see here, digital devices. These are for things like sensors, LEDs, those kinds of things. And then once you're done with all of that, you hit done, and then you save it, and you save a name for the config. And then you can look through your list of configs and you activate the one you want. And that basically allows you to kind of, if you have different programs you want to run, it allows you to have not have to rewrite all of the config for each one. So something very important, which hopefully you won't have to learn, is disconnecting. So avoiding disconnects is a really big deal, because obviously if you disconnect during a match, you can't really do anything, and that always sucks. So make sure all of your wire connections are strain relieved and they don't come undone by your robot moving and a wire getting tugged out of its port. Make sure your batteries are fully charged. If a battery dies halfway through the match, that kind of sucks, and it also means that your robot is running at its fullest capacity. Make sure the Wi-Fi spectrum isn't too saturated. This is something that, like I said before, hopefully will happen at tournaments. They'll tell you what to connect to so that this will be minimized. Use a rev grounding strap. That'll help reduce static on your robot, and spray anti-static spray on the field if you can. You might not be able to at tournaments, but while kind of practicing at your own field, it's useful to do to not cause static to short your robot. And make sure there aren't any frayed wires that would lead to a short by bumping into some other part of your robot. So if anyone has any questions, now's the time to ask them. You can either say them out loud or you can put them in the chat. If you have any questions over those previous slides. We'll have multiple other question breaks for other sections, but if you have anything right now that you want to ask, you can. All right. If there's nothing, then we'll continue on. All right. So next we're going to talk about different ways to program.
Hey, Ben, there was a comment in the chat.
Did I miss it? Oops, sorry.
Just came in.
2020 plus the kit comes with the control hub in the competition kit. I did not know that. That's very good to know. So you probably won't encounter you probably won't need to use 2 expansion hubs in that case, which is good. The control hub is very useful for it's a much simpler thing to work with, and it is stronger. So I'm glad that that's in the kit now.
I believe they give you the option to order it when you register your team. I know there are some shortages at Rev right now. It's been out of stock for quite some time. So hopefully if you're ordering it, you can still get it. I know Rev was having a buyback program and some other things. So I would check the forum or other places if you're looking for it and not able to find it. You might pass, there's teams that were potentially willing to sell or share their extras as well. So.
Okay. So if nothing else pops up, we'll continue on. So we're going to talk about controllers on back order, though. That kind of sucks. They're you can use many different kinds of controllers for FTC. Luckily, I don't know exactly what the legal list is. I'd assume that's in Game Manual 1, but hopefully you can get a controller for that.
There are 3 big ones that most teams use. Most teams will use a PS4 DualShock, an Xbox 360 controller, or a Logitech. I want to say it's the F310.
So if there's nothing else, we'll continue on. There will be more options for questions later on, so don't worry if something comes up last minute. So next up, we're going to talk about different ways to program. So there's 2 main styles of programming. Blocks, which you can see on the side, you may be familiar with, and Android Studio, which is kind of more Java and like traditional coding. So block programming, it's great for people with less experience programming or for smaller programming teams. Very easy to visualize what's going on in the code, and you don't need anything more than a Chromebook to program. You can really use anything for it. You have to remember to back up your programs just in case, which is a little unfortunate. And you can't do super fancy stuff or use other people's code, but you can do well with just block coding. It's definitely not a hindrance. It might be a little more difficult, but you can definitely do some great things with it. And First has an amazing programming guide for block programming, and we'll see if we can put that in the chat so that you can have access to that. Alternatively, you can look up First's programming guide. They have a bunch of resources on it, downloads for things. They have these guides on them, all kinds of stuff, very useful. And obviously it's First itself, so it's very nice to have.
Igong Benjamin, di parang sabihin mo yan. Nakadema nila na
Next up, we have Android Studio, which is kind of our more traditional word-based Java programming. It's the best option for more experienced programmers and for larger programming teams. It uses the Java programming language, And you can use other people's libraries for classes, especially useful for things such as vision. And you can collaborate with others easier using GitHub, which is, long story short, a website that allows you to work together on the same code and with more seamlessly. It has features to help you write code. You unfortunately do need a Windows or Mac, and it takes a considerable time to set up fully. And you occasionally have to deal with back-end issues, but once you get through all of that, it's a very powerful tool and allows you to do a lot of incredible stuff. First also has a guide for this, so we'll probably get that in the chat as well. It's also in that programming guide that you can just, if you just look up first programming guide, it's also in there. Once again, great for kind of going over everything. All right. So if anyone has any questions over that or anything else, you can ask them here. You can just pop them in the chat and we'll respond, or you can say it out loud if you want.
Okay, I heard.
What do you use? We use Android Studio, and we've been using it for I'm pretty sure the entirety of our team's existence. We just really like how powerful it is and all the things that it allows us to do and collaborate very easily, which is great because our programming team is moderately sized, like 4 to 5 people. So it really allows us to work together, and it's really powerful in all the things it can do.
Can you go over the I/O available on Blockly?
I do not exactly know what Blockly is. I'm sorry if I am not understanding your request, but I don't know what that is. Oh, okay. Like what do you want me to go over block programming? Because I can go over a lot.
Oh no, I just wanted to take a look at the IO types, different IO types you have, like DI motors, just the framework of that.
Okay. I'm pretty sure it also kind of has the same stuff, like, motors, and you can run servers or servos and sensors and stuff through that. And blocks is almost the exact same as normal Java programming. It's just kind of formatted a little bit differently. But besides that, I'm pretty sure, I'm not 100% sure, but I'm pretty sure that it has all the same capabilities, if maybe not all, but most.
So there's no new type of IO like vision cameras or anything that you can use using the Java side and not available on the block programming side, right?
I'm not 100% sure, but I don't know everything, but I'm pretty sure that anything that you can use in Java, you should be able to use in blocks. There might be a couple things that you can't use in both, but hopefully and probably you can.
Thanks.
You're welcome. I hope that cleared it up. If anyone else has anything, if no one else does, we will continue on. There will be a couple more question breaks, so don't worry too much. All right.
Awesome. So now we're going to cover some basic programming. So this is what you would use in Android Studio. So this is just the basics of Java and how it applies to First Tech Challenge. So the first thing we're going to discuss is variables. Could you move on the slide? Perfect. So variables hold information in memory, and they can be created or edited by the programmer. So the example here is of the Boolean type. So the format is the type, the name, and then the value. And then so you need to have that equal sign in there to declare it. And then so there are multiple different types of variables. So those would be integer, so that's just a number with no decimal, a double that has a decimal, a character, which is just one character, and then the Boolean, which is a true or false like data. And there are a few other data types. They're just not really super applicable. You can always just find them on the internet. And then so we have some objects that are used a lot in Java and FTC. So those would be like strings. So that's going to be a line of text or like a group of characters. So you would need a string in order to put together a word. And then DC motor, that's a type of motor that we use. And we have quite a few others. And then so at the bottom right there, we're going to post that in the chat, is a overview of just different variables in Java from W3 schools, which is actually a great resource if you just need any help on Java. So this is going to be on the Logitech FTC controller, what some of the inputs, what types they are. So like our bumpers and our buttons are Booleans, while our sticks are going to be floats, which are pretty much the same as doubles. And then our triggers are also floats. And so here are some examples in our code of variables. So the first one is from our PID class, and then these are just some of the fields from there. And then we have our odometry class. These are just some of the different variables that we had to declare. And then so our next big topic is conditional statements. So these are going to be less than or equal to, greater than or equal to, and not equal to. So it's just the common signs that you learn in math class, except with the less than or equal to and the greater than or equal to, it's followed by an equal sign. And then the equal to, you have to have the two equal signs in there. So it has to be A equals B, because otherwise it would be declaring A as the value of B. And so that isn't what you'd want to do there. You want to set them equal to each other. So you need two equal signs. And then the not equal, you're just adding an exclamation point before the equals. So if else statements are how we evaluate conditional statements. So what you would do is in the conditions in that if block right there, you would put in a conditional statement, or you can put in a Boolean. And then if that statement, if the conditional is true, then that block of code inside of the if statement is run. And then it just exits the whole if else chain. So if it's false, then it will run onto the else if right there. And then if that's false, it will go to the else. So what you can do is you can actually just use ifs. You can just use an if and else, or you can just use an if and an else if, but you need an if to have an else if and an else. And so here are what some of the ifs and else ifs look like in our code. So here's our ARM class from last year, our update method. And then here is our autonomous from worlds last year. This is just an if and an else from that. And so loops, those are also very important to programming. So that allows you to run over code multiple times until a condition is true. So the most common type in FTC is the while loop, which is very similar to an if statement. So it's while this statement is true. So like while A is greater than B, or while a certain number is equal to another number, something will run. And so it's good for just executing code, because you can just write code. Like if you need to run something 5 times, it's easier to use a loop than to just write it out, and it just looks nicer. But then it's also great for something, if you're getting an input, it allows you to run it that number of times. So it just allows you to utilize inputs better in your code. And then we also have another W3 schools overview of loops that'll be in the chat. And so here are some examples of loops in our code. So this is from all of our autonomouses. It's based off of a while loop. So while the op mode is active, the code inside of the brackets will run. And then so here is another specific while loop from our worlds auto. So while the auto isn't started, and while the stop isn't requested, this block will run. So methods are very important in Java. So methods are inside of classes. They're just a smaller string of code, like an update method or a write method. Or you can also have a method to do a specific function. Like if you want to move up an arm on the robot, you can have a move up method or a move method that takes a number, and then you can say how much you'd like to move it. So it's essentially just the definition is a collection of code that can be called elsewhere. We have some sample code on there, but then I actually have methods on the next slide, so we can just click to that. So these are inside of methods from our autonomous in the worlds auto. And then so we're going to be talking about classes next. So a class is a collection of code that is usually in a separate file. So the .class file, it can have methods and variables inside of it. And then so that it's essentially a blueprint for an object. And so that object is going to have all of those methods and all of those variables stored inside of it. So if you'd like to call a certain field or a method from another class, you can do so using objects created from classes. And so you can actually make multiple objects from the same class. And so we have a W3 Schools overview at the bottom of the page. That'll be in chat. And some examples of classes. Our code is based off of classes. These are just a few of many. So like our drive test, which was how we were testing our drivetrain odometry, and then that was our teleop from worlds. And then so when you want to create an object from a class, so anything that is not a primitive type is going to follow this format. So it is going to be the type or like the class name. So in this case, it's location. Then the name of the object that you're creating. So this one is position equals. So you're declaring a new object, new, it's new, and then location, the type. And then in those parentheses right there, you would have any parameters if you were running them in the code. In this case, the location class doesn't take any. So it allows for you to create objects. And then so I talked about before how a class is essentially a blueprint. When you create an object from the class, you are using that blueprint to build something new. And so you're using non-static methods from the class, because without that, you wouldn't be able to use those methods. And then so our op modes are the programs for the robot. So we have autonomous and teleop. Teleop is just driver control and FTC. So the autonomous is when the robot is running completely by itself. We just hit start and then it runs. And then the teleop is the next phase of the game. It's where there is a driver or two drivers controlling the robot. So you create an op mode by extending linear. You extend op mode or linear op mode in the class header. And then you're going to use an annotation like shown below to give a little name for that op mode. So in this case, it's button op mode. Does anyone have any questions about anything programming related, like just Java?
So when you switch between op mode and teleop mode, you switch the programs, right? You'll have two separate programs for the autonomous mode and a separate program for the teleop mode, right?
Yeah, so in the object-oriented format that Java uses, you're going to have separate classes for that. Each mechanism has its own separate class. And then you're going to have, you can run the autonomous class and the teleop classes from the driver station app. But yes, they're separate classes. And this is all Java. So you can take this as intermediate or advanced, but this is the, I guess this is more beginner, but this is the framework for Java coding. So if you are going to code using Java, this is the stuff that you're going to need to know.
You can always start in block programming and take the code that it generates, the Java code that it generates, and then start massaging with that, right? There's always like a back and forth, or do you have to start in one?
I haven't done a lot of block programming myself. I'm not exactly sure.
Okay.
I'm pretty sure that I think it depends on what kind of program you are using for your block programming, but I am pretty sure that most of them do allow you to generate like Java code from your blocks. So I'm pretty sure you are able to do that.
And so you can't use Python to code. So FTC only allows you to use Android Studio for Java to code. It's just the object-oriented format is what's best for FTC. Do we have any other questions?
All right, if there's nothing else, we'll continue on to our next little section.
So if you have to implement object-oriented programming, it's just the structure, right?
Yes.
How
it
you
is.
format your code. Okay.
Yeah, so object-oriented programming is essentially just using each class for its own purpose. So like you're creating a class for each mechanism, and then you are creating a class to use these mechanisms. So like our teleop uses a drivetrain, and it uses an arm mechanism, let's say. And then so this one class is going to utilize other classes, and it uses these fields and methods from that. I can give you a much more in-depth explanation, but I don't want to bore you with that. But object-oriented programming is essentially just allowing you to use different objects and then extend objects and a lot of that stuff. But you can do it doesn't have to be too complex with what you're doing with object-oriented programming. It's just the structure pretty much.
Okay, thank you.
All right. Next, we're going to be going over understanding the hardware, because you need to know what you're working with in order to know what you can program. So how do we get to the hardware in the first place to actually be able to, code it? So first, you create an empty variable of the type of device you're using. So as you can see here, you'd make a DC motor and then name it whatever you want, in this case, mot. And then once the op mode or autonomous has started, you assign that variable using a hardware getter, which you can see here, mot equals hardware map.get DC motor.class, and then the device name is intake left. That's all a lot, but in general sense, what that means is it is telling the code that in your configuration that you did on your phone, whatever port you assigned and called intake left, it'll run all of mots. So whatever mot is, whether that be like driving or like moving an arm, it'll run any of that motor's code through that port. And the hardware map is automatically present in op modes. It has a get function. The device name is from the configuration, like I said, and the first parameter is what type of object or device is being gotten. So DC motor, servo, CR servo, any kind of sensor that you might have, all that stuff goes there before the dot class. And some good places to find this code are example op modes, Google, and FTC's Android Studio Guide, which we have put up before, but we can put that in the chat again. And what do we control? So there's two main things that we use to move stuff on the robot, which are motors and servos. Motors, you can only have a maximum of 8. They're continuous rotation, so they rotate continuously. And they're the most powerful motion in FTC. They're good for drivetrains because you obviously need to move your entire robot, and heavy duty mechanisms. So like if you have like an arm you're rotating that has a lot of weight on it, those are very good things to use motors for. And you control it by giving it a certain amount of power, and that's how much power it'll apply to its rotation. Servos, you get a maximum of 12, and they either have a continuous rotation or just standard servo mode. Continuous rotation kind of acts like a little smaller version of a motor. You just give it a power and it rotates that amount infinitely until you tell it to stop or change its power. While the normal servo mode allow you to set a position and then it'll rotate to that exact position every time, which allows you to kind of have like a toggle if you have like a flap you want to open to 2 positions. Servos are great for that. They're great for moving light things, releasing things, and you give it power. You give it power if it's continuous rotation, or you give it a rotation setting if it's a normal servo setting. So motors, they're stored in instance fields, as you can see here. DC motor front right, so that'll be our front right motor on our drivetrain or whatever. They're initialized by getting the motor object from hardware map. So this is that line of code we showed before. So if you have DC motor before the dot class, then it'll obviously initialize a motor. And at initialization, you set the motor to whatever zero power behavior is wanted. Basically, what this is there's a couple. There's float, I think brake, and maybe one more. I'm not 100% sure, but float and brake are the two main ones that you'll use. What float does is when the power on the motor is set to 0. So if you're running the motor at full power and then you cut all power from it, like you're like, okay, stop running, it'll keep on spinning a little bit. It won't like try to resist. If you have it on brake, then when you set the power to 0, it'll try to run the motor backwards a little bit to try to like stop in that exact spot and not like drift any. And you can set each individual motor at the beginning of your op mode. And if your motors are backwards, which they usually are based on how a drivetrain is typically built, you can set the direction of them to be reversed, which allows you to use powers of 1 for all of your motors instead of needing to make some of your powers negative based on what direction they're going and if they're the reversed motors or not. So running to a specific position, you set the mode to run to position with the set mode method, as you can see on that first line of code. And then you set whatever position you want it to run to, and then you set the power that it'll run to position. So this is useful for being able to move a motor if you do need a motor to run to a certain position. So like we said, an example, if you have like an arm that's really heavy duty, has a lot of weight on it, and a servo just like won't be able to power all of that, and you have a motor but you still want it to only go to like 2 or 3 positions, then you can use run to position, and that allows you to more fine-tune where your motor goes to. And then obviously you can set a target position, which is where you want it, and then the power, which is how fast it'll go there. And you need an encoder in order to do this, and we'll get into encoders a little bit later, but you need an encoder in order to be able to run to a specific position with a motor. So servos, there's 2 types of servos, like we said before, normal servos and CR servos. Normal servos go to a set position. CR servos go at a certain power and infinite rotation. They're initialized with hardware map, so this is almost the exact same as with motors, obviously with a different thing on the left, obviously servo and CR servo instead of motor or whatever, and a different device name. You can make them the same if you want, I guess, but the main difference is servo.class and CR servo.class based on whether it is a normal or CR servo. Servos go to position, and CR servos rotate at a variable speed. So servos use dot set position, and CR servos use dot set power. So what are inputs to actually affect these things that we're programming? So the two main ones, the mainer one of the two is the gamepad, which is obviously what you're going to be using to control most of your robot. But the other one is sensors. These can be all kinds of sensors. It could be a limit switch, a bump switch, a color sensor, an ultrasonic sensor. There's all kinds that you can use, and they also act as inputs for your code. So first off is gamepads. Up to 2 gamepads can be used, and you get a lot of information from them, a lot of buttons, a lot of things you can do with them. They're present in all op modes. So that's teleop and autonomous. They're present in everything. Obviously, you don't use them autonomous, but in Java-based programming, it acts as a variable. And to access the code, the structure is gamepad1 dot whatever button or stick or trigger you want to press. So for example, if you want gamepad1's left stick X, which is just a very fancy way of saying the left and right on the left stick, then you would say gamepad1 dot left stick X. And as you can see over here, these are some examples in block. There's a handy dandy reference. And if we go to the next slide, which we can pop that reference in the chat, and the next slide is also that same reference, which we saw earlier in the slideshow. So if you can go to the next slide. So this is the reference sheet again, with obviously all the floats and booleans, and in the kind of darker orange is the name that the code recognizes all these buttons as. So for example, like you do like gamepad1 dot dpad underscore up or gamepad1 dot right stick button. These are all the names that the code recognizes, and obviously you use to read the button presses and stick inputs. So we're going to talk a little bit about sensors. All sensors are used a bit differently, so you need to obviously understand the basics and find documentation, because obviously a distance sensor is going to work much differently from like a bump sensor limit switch. One of those. Most sensors are made by Rev, and they have documentation for them in SDK and the form of examples or JavaDoc. Those are really handy to look at because they kind of give you a good insight on what each sensor does. Generally speaking, in Java code, you make an empty variable, and then you initialize the variable with the hardware map, just like motors and servos. And then you get that status of the sensor from the variable. So that could be a Boolean if it's like a limit switch on or true or false, pressed or not. It could be like a double for something like a distance sensor for like how far away something is in like millimeters. But whatever you get from the sensor, it's stored as a variable. And then you can use that variable to compare stuff and run things. And this is these are encoders, which I mentioned earlier when talking about specific position motor runs. So if you want to run a motor to a specific position, I said you need an encoder. They are extremely powerful sensors. They're built into motors, and they will tell the program how far the motor has gone. So every encoder has stuff called encoder ticks. For example, let's just say an encoder has 5,000 ticks. So when the motor goes one full rotation, then the code knows, oh, that's 5,000 encoder ticks that it's gone. If it goes half, then that's 2,500 ticks. And it allows the motor to be very precise with where it is, and allows the code to know how much the motor has rotated from its initial position or its previous position. They make for repeatable actions similar to servos, similar to normal servos. So while a CR servo kind of acts as a mini motor, an encoder motor acts as kind of a more heavy duty normal servo. So like I said before, in a case like you have a heavy duty arm that you need to move to like 2 positions, you'd need a motor with an encoder in order to do that. They need to be plugged into work, and you just plug them in next to the same port that the motor is. And they may require level shifters, but usually they don't. So if anyone has any questions over any of that stuff, this is our last question break. So if you have any questions over anything, feel free to ask right now. You can pop in the chat, say it aloud. But this is our last question break. So ask anything you have over anything we've gone over so far.
Yeah. So regarding the encoders, what information that you see from the motor? Like, does it give you the health of the motor, or just, or is it just the position?
It just gives you the position of the motor in the amount of ticks that the encoder has rotated around. So like it's kind of the motor itself doesn't have a way to tell us how far it's rotated. So the encoder kind of like does that job for us and like pretends that it is the motor. And that might have been a bad way of stating it, but the encoders just show you how far a motor is rotated in based on how many ticks it has.
Okay. How about the speed of the motor? Like if you, instead of running at full power, if you want to slowly move the arm up, uh, can we slow the movement using the encoder? Or
You
is it
can't.
just the power level that you have to change?
Yeah, it's just the power level that you set it in the code. So you can obviously change that in whatever you want to whatever number you want. But the encoder itself doesn't do that. That's something that you do in the code. So if you wanted like a slower movement, then you'd set the power to like 0.3 or something, depending on what your fast movement was.
Okay. Also, for the sensors, do you see the parameter? Like if it is doing distance, you say stop 10 centimeters from the obstruction. So while the robot is moving, do you see the parameters that the sensor is detecting?
Yes, there you can. That kind of updates in real time, and there's something called telemetry, which you can use to kind of. It's basically Android Studio's version or like Java's version of like printing lines, and it allows you to kind of to print the variable of how much this sensor is seeing, and then while you're running your code and you're doing the match, you can look on the driver station on the phone or the hub, and it'll tell you like how much the sensor is, which allows you to kind of test things or just like see in real time how it's updating, if it's working properly, stuff like that.
Okay. For color sensors, is it a number based, like, blue is a certain number, black has a certain number, or does it really tell you color blue or color black?
So for color sensors, they're a little complicated. I am not the best person to ask about that. But I do know that it does work in a number system. There's multiple different ones that you can work with, whether it's RGB or like RYG, I think, or YG magenta. I don't know, but there's like multiple different color systems that you can work with, and like it's usually a string of a couple numbers. Color sensors are more complicated, and that's definitely something that luckily Rev should have good documentation on that to be able for a specific color sensor and how that one works. But it usually is like doubles or integers of like different values to like kind of combined for your RGB values to tell you what color it is. So it's a little bit more abstract in a way.
Yeah. The most interesting sensor that I'm interested is in the camera flow. So when you hook up a camera as a sensor, what is the controller actually seeing? Is it like, is it doing image processing in it, or what do you kind of, because it could be anything, right?
Yeah, so when you put a camera on your robot, on its own, it doesn't do too much. There's a lot of things that you can code it to do. So, for example, you can tell it to have a certain like box on the camera, and then it searches for a certain color in there. You can check, depending on your camera, it might also work as like a kind of little distance sensor. So while the camera itself on its own doesn't do much, you can program it to do a wide variety of things based on whatever you want to be able to do based on what it sees.
Oh, okay. So it's like a multifunction based on, it can based on code, it
Yeah.
can be adapted. Okay. So TensorFlow is what I have heard you use. Is that the most common one to do the camera input on?
I'm not the expert on the camera, but there's I know that there's many different things you can do it through. I don't know exactly what's the main one or what people regard as the best one, but that's something that you can hopefully look up, or you can ask around on like the FTC forum or Reddit.
Okay, thank you.
You're welcome.
What did you guys use last year, Ben? You used computer vision, didn't you?
I do not know exactly. That would be a Luke question. Luke, do you know the answer?
Oh, he's in the waiting room. Hold on. He jumped out.
No. Oh yeah, we used OpenCV software in combination with Grip Pipeline. I'm pretty sure that's what we used last year and the year before, but I definitely know that there's a lot of other ones that you can use for that.
Hi, I just had one more question. Do you have the list of inventory of the additional components that you ordered other than the standard box? And probably if you have made some note like this device for this purpose, do you have that kind of inventory? And can you share it, please?
I'm pretty sure we might. I'm not 100% sure.
Are you looking for a list of electronics or a list of like hardware and motors and things like that?
Yeah. Hardware motors. Like again, we have got as a team the standard kit. Just we are the beginners. But just to get a feel of when you guys ended up finally, how many additional components that you ordered other than the standard base set, and how and what was the purpose or the necessity of those components each?
We can probably put together a list of kind of some common motors and things, and sensors that we use. But this team's been around, this is going into their 8th year, so they kind of have a accumulation of a lot of things. They mostly build with, they'll build us stuff right now, but but use a lot of Rev things as well. So we can email that out after sometime in the next week. So
Okay, that would be wonderful. Thank you.
Yeah, and electronic components like that, obviously there are some things that you might not find a use for in the robot that you're currently building, but maybe the next year or maybe like a future version of your robot or a past version of your robot utilize that. So it's more on like a case-by-case basis. So it's not like you use a limit switch in like every single robot. Like there might be situations where you do, there might be situations where you don't. It's really very dependent on what you have. But there is definitely like some general ones, and we'll try to get that out, like a general list of useful to have like servos and electronics and motors and servos and stuff like that.
Understood. Thank you.
Okay. Any other questions you can ask or you can put in the chat? All right, I think that's it.
Oh.
Obviously,
Oh, so one question is between the control hub, not the hub, but the rev controller that's on the robot and the expansion hub, do you see more than one expansion hub? Like, if you have max 8 motors that you can connect to, does a typical FTC robot has more than 8 motors and 12 servos?
So I'm pretty sure 8 motors and 12 servos is the limit that you're allowed in FTC, which is exactly how many ports that 2 expansion hubs or expansion hub and control hub have together. So I'm pretty sure that 8 and 12 are the limit for those 2, and that if you have more, then you won't be allowed to like compete. So I'm pretty sure that's like the upper limit that you're allowed.
that is the
Okay.
FTC rule. The limit is 8 and 12. And
Okay.
you can see more details about that in the game manual that came out. If you go on first website. The game manual 1 came out yesterday, and it has a list of all the hardware rules and kind of robot rules are in there.
Okay. So you definitely need one control hub and one expansion hub. Oh.
Yeah, you need 2 hubs because assuming you use 4 motors for your drivetrain, if you want any other motors, you need a second hub, whether that be an expansion hub to go with your control hub, or if you are using 2 expansion hubs, a second expansion hub. Is Java the only language you can use for coding, or can you use others like Python? I am pretty sure that for FTC specifically, you need to use Java. I think that's just how it is, unfortunately, so you can't use something like Python. So if that's everything, if you have any other questions, you can email us. We'll have our contact information in a couple slides. So kind of what's next? Try making a program from scratch. Try making a drivetrain, an intake, whatever. The best way to kind of learn how to code is to actually do it yourself, because that kind of teaches you how to do it in the engine that you're going to be using, and kind of troubleshooting, bug fixing. It's a much better way than just reading about it. Like actually doing it allows you to learn that stuff much quicker. And obviously, at a time before the game is revealed, you want to fail and learn now rather than like after the season has started and like you're putting together the robot for that first competition. If you don't know how to do something, Googling works a lot. Obviously, internet has a lot of great resources. You can check out references that we linked in this presentation. You can reach out for help online. There's an official forum, there's an unofficial Reddit, and there's an unofficial Discord, which are all great resources if you need help with not just programming stuff, build related things, business and outreach related, all kinds of stuff like that. Those are great resources for those kind of things. And we have a couple miscellaneous resources here. There's a really cool free book about Java FTC programming. The FTC SDK Java doc, which helps go over kind of the SDK for FTC and all of that stuff. FTC's own Android Studio guide, or their block programming guide, which we have linked to before already, and you can just look up FTC programming guide. Tons of information there. Codecademy, which is a very good way to kind of learn basic Java, and obviously FTC programming resources, which is that overall thing that I said that has all the links to the Android Studio guide, blocks guide, like downloads for things like that, and like libraries. A lot of amazing stuff on there. And if you need any help, you can contact us on Twitter. We're at Bionic Tigers FTC, or through email. We're bionictiger764@gmail.com. We're happy to help with anything that involves building robots, programming and bug fixing, and help with that kind of stuff, fundraising, feedback on Engineering Notebook, etc. We specialize in a lot of things, and we like helping people out. So if you ever need help with something, you can contact us if you want. And if not us, another great resource is the FTC Discord server, because there's all kinds of teams on there who would also be happy to help you out. And that's everything for the presentation. So I hope you guys learned something. I hope you took something away that allows you to program better. And I hope everyone does great in their season.
Yeah, thank you. This was really useful.
You're welcome.